Yesterday, section 3.3. What do we? Who are we? That's not us. This is us. Whew, let's not do calculus today. All right. Someday.
Oh gosh.
We're almost to. We're not in homework number. What? Oh, Santo, this is 21, right? Okay. We have 2 examples, but before those 2 examples, we have one more we didn't do. What properties? There we go. What properties were we working with yesterday, guys?
Product, quotient, power.
Product, quotient, power. The 3 most common properties of logarithms. The ones that we did in section 3.2, they're important. The one-to-one property, the inverse property, the random other ones that probably don't really make much of a difference properties. Anyway, oh no, there was one. This is one I bet a lot of you are forgetting. Good question. What is log base 7 of 1?
0.
Why? Because 7 to the 0 is 1. Okay, hold on. Okay, I'm going to make it crazy. How about log base 132 of 1?
0.
Because 132 to the 0 is 1 too? Oh, that's true. What if I do ln of 1?
E. 0.
Why 0? How would you show it? E to the
0.
is still 1. What's anything to the 0 power?
1.
So what's logarithm of 1?
1.
Any logarithm of 1?
0.
0.
Got you.
That was close. Any logarithm of 1 is who again?
0.
Okay. That was one of those properties that you really should know and a lot of you forget and then you just start writing random things down. Anyway, besides that, these properties are pretty stinking important. And the first thing we saw was you can rewrite weird problems with the properties and kind of make them look simpler. But I think the hardest thing on this example, it's okay, let's own it. The hardest thing on this example yesterday was what step?
Third.
Right here? To make 2 to be the square root of 4, that's rough, right? But let me just see if maybe you guys are a little bit more prepared for this kind of weird thinking by giving you another example. What if I was to give you something like, ready? Log base, let's do 49 of 7. Not negative 2, but good idea. Let me do another one too. How about that? Log base 7 of 1 over 49. Let's start with that one. Do we like that the 49 and the 7 don't match? Oh, that's no fun. We have that cool property, log base A of A, and everything's all nice. So we really want 7 to be in terms of 49. Jason, so what will we do? Yeah, but just for those who are like, huh? Let's put 49 square root first. Does that sound good? We can change 7 to be the square root of 49. They're related. 7 is just his square root. His meaning 49. I'm not sure why is this on.
Okay, I get that.
It's. Now what can I do? Jason, why'd you say 1/2? It's the same thing. A square root is a fractional power. So now what can I say? Well, we need to use the property that says inverse property. He undoes him, and we just end up with 1/2. Or we can use the nifty power property and bring him in front and say, well, he's just 1 times 1/2 is 1/2. But either way, the final answer is 1/2.
Yay.
Now, how about him? We don't like, first of all, the 1 over. Any ideas? Yeah, we can bring it on top, but we just have to make the power be what?
Negative.
A negative. I'm just doing negative 1 because I left the 49. But what can I do with 49? Most of us see this easier than we see that one, but it's okay. How can I rewrite 49 in terms of 7? So I can do log base 7 of 7 squared to the... Ooh. Isn't there a rule? Nice. We saw it yesterday, right? So log base 7 of 7 to the negative 2. Same dealio. Now some of you can make that jump, and that's awesome. Some of you can make the jump all the way to here, and that's awesome. But I'm just connecting all the different in-between pieces for those of you that need to see more. So what's the final answer?
2.
Are we as scared of this as we were yesterday? Maybe not. right? So just give it some time. Sometimes math just needs a little bit of time. Sound good? Okay. Let's keep going though. Then we started talking about two big words. Well, I mean, they're not big, but important, right? Expand. What was the other one? Condense. Like condensed milk. It's really thick, right? And amazing. But
Ew. That's so disgusting.
Actually, condensed milk.
Oh,
I'm apathetic.
Really so sad. Vietnamese coffee.
Oh.
Anyway,
Second Amendment.
Second Amendment.
First Amendment. Second Amendment's guns.
It's okay, you guys aren't done yet. We'll just let's go back.
Yeah.
Alright, focus on it. We have expand and we have condense, right? We can have fun as long as we come back and focus. Expand and condense. Who can, in your own words, well, I guess I kind of have my own words up there, and your own words might be similar. Does anybody have any different own words as to how to describe how to expand?
Make bigger.
Make bigger? Kind of. To tear apart, now, question. When we tear apart, pull apart, tear apart, so you're violent. Anyway, a logarithm with a single argument. How many logarithms are we usually, with our properties, going to go to? A single log with a messed up argument into 2, right? So single log, messed up, or I should say, very packed argument, is going to split into 2 logs with either a plus or a minus with simpler arguments. Okay? But we have to follow our properties. So yesterday, do you remember my little clues? I don't know what I just hit. I think it's open. Random. Cancel. Okay. Do you remember how I said to remember, or how I said to use the properties when there's more than just 2 things being multiplied? Whenever you do a multiplication or read, I think it's easier sometimes to read the multiplication 5 times. Whenever you read the multiplication, keep going, Nathan.
Whenever you read multiplication, you put a addition sign.
Plus and then an additional logarithm, right? So, when I read log base 4 of 5 times, I say log base 4 of 5 plus an additional logarithm. Keep going. X cubed times plus an additional logarithm, y. Okay? And then why did I keep going? Well, I could make this argument simpler by just pulling down the power. Cool. Now, over here on this side, what was there, or what could I have read as I was reading the problem that should have gone to the minus an additional logarithm?
Quotient power.
Yeah. The quotient rule, and then eventually the power rule. The quotient rule, ln of this dude divided by, So I write ln of the top divided by minus an additional log. Which one do I have? Ln, so rewrite him, and then write the bottom. Then I can make the square root into a 1/2, bring the 1/2 down. Suddenly I have simpler arguments, but multiple logarithms. Which one? Well, the one we started with, ln's. Okay. This was what again?
Quotient.
We're using the properties in order to expand. So then we barely got into condensing. Let's spend just a little bit longer on him. If expanding means to pull apart, hopefully condensing kind of makes sense to bring together. Yeah? Smash together. More violence. Anyway. Football players. It can be useful when
You're trying to
contained, harnessed, controlled.
So you can fill puppies more efficiently when you're a football player.
Or you're just Tyler and you say,
I'm not sure if that's a compliment or that's a dig. Let's ignore that. Anyway, let's cut that from the video. Jason has been answering a lot of questions today.
Oh, that's true.
Is it, huh? Come back. Condensing. Putting together. Safe place. Condensing. Bringing together. Hey, bringing together. Yeah, some of you need that. Anyway, bringing together. Sums and or differences of logarithms into a single logarithm. So you have them all separated. We need them back together. But there was one quick little note I had to make yesterday. If there is some place where you can apply the power property, but backwards. You have to look at these in a different light, in a different way. Because, let's go back to those properties really fast. How are the properties written? Single log pulled apart, single log pulled apart, single log pull down, whatever. The properties are written as single pulled apart. They're written like little expansions. To condense, what are we going to have to do? Go
Backwards.
backwards. So when you're looking at the properties, trying to condense, just think you're looking backwards. It's spread apart. You have to undo. So the first thing we have to undo in any of those condensing problems, if it's there, if there's a coefficient in front, I have to pop them up into a power. Okay? And that's why in yesterday's example, the very first thing for condensing, I said, uh-oh, there's a coefficient. I have to pop them back into a power. Then, just in case you guys need to see the in-between, I could have rewritten this as log of x. And if there's no base, what is this log again?
10.
Common log with a base of 10. And I could say log of x plus 1 squared. Now I can say, that's a 2. Struggle. Don't know. I have log of one argument minus the same log of the other. Now that I have no numbers in front besides 1, no powers that need to pop up, I can say, sweet. The minus gets changed into a what? Division, but careful, common mistake. I'm going from expanded logs to a single log, right? So when you read a minus, you have to eliminate a log and make a division, okay? Log base x, sorry, not log base x, log of x minus log, eliminate the log, make a division, x over x plus 1 squared, done. It's condensed, it's a single logarithm, and we're good to go. So you guys, you might be a little bit harder. I'm going to give one clue, and the clue is maybe bring in this 4. First, condense him as far as you can go. Go. You yourself and you, then in groups will take you like 30 seconds to collaborate. My hint would be to bring in, there we go.
Good job, Ricky.
Don't die. Would be to bring in the 4. Then, try to follow the steps to condense it as far as it can go. Remember, you've condensed it properly. At the very end, there should be a single logarithm. And in this one, a single log base L. A single ln. English, isn't that juniors?
No.
Groups collaborate. You might not be all the way done, but talk it out.
My group.
No judging. Safe place in your groups.
Alright guys, so
Check front with back with front, diagonals check.
safe place, Ricky. This is a safe place.
Ricky, wrong group. Reach out.
I got ln z4 z4 plus 625 is z minus 5 1 power 2.
Alright, did you get this?
Oh, sorry, because I like z to the power of 5, or z to the power of 4 and 5 to the power of 4. Wait, is that
The Z.
let's do it. Is that the answer? No, it's not the answer.
Hold on.
Yeah,
Never mind.
Talk it out with the group, see if they agree or disagree.
I just decided to solve it, or try to solve it as much as I could.
What language is that?
It's Hebrew. You actually have to read it like
Right, I've written one more step. Do you agree?
Yeah.
First thing is undo the power property.
Yeah.
First thing is undo the power property, right? Otherwise, it's going to go really illegal really fast.
Why is it
Legal.
illegal to use this?
Whoa, what is that thing?
Conic sections. Did Mr. Crawford?
Did you do the light through the stringy thing?
No, are we learning? Yeah, we did. Are we learning about it?
She didn't like it.
Why is it illegal to use the product property before you distribute? Why is it illegal to use the product property before you
So we have to make the coefficient of powers first, and then it matches our properties, just having logarithms with the number of 1 and 5. So then, kiddos, let's see. You can technically do it all in one step. You have to be careful. We're going backwards. When I read ln, I say, okay, fine, there's going to be an ln. It's going to be a single one, right? The big old nasty argument. Z to the 4th plus ln. I eliminate the ln and I make the plus into a multiplication, the product property. So I do z to the 4th times z plus 5 to the 4th. So far, all I've done. ln, okay, keep the ln. Z to the 4th plus ln. Ooh, eliminate the ln and change it to be a product. A multiplication, bring them in. Now, keep reading. Minus ln, eliminate the ln and make it into a what?
Division.
Division. Check it. Does it make sense? Now, it doesn't mean it made sense a second ago, but does it make sense now? The addition of an ln, you eliminate the ln and say, no, you were really, you should be really, I'm condensing you to be multiplication. Minus ln, eliminate the ln, make it division. Or divided by.
Do I have to find that out?
No, just leave it all nice and backwards. Because usually we like stuff backwards, so we don't have it just like that.
What?
This is my preferred version. Because anything else will just cause frightened results. Which it is Halloween, but let's not do that then. Okay. A couple more examples, although we've done really good examples of expanding condensed. I literally have 2. This page and the next, and then we're done, and we still have about 25 minutes. Maybe get through our 2 examples, and then see if anybody who did homework can already be like, hey, these are hard, guys, let's look at them with her. Okay. Your instruction. Can you use what we did earlier today when we were talking about logarithms of weird arguments and not exactly matching to simplify this without your calculator? What don't we like first? Yeah, the division number 1, the square root number 2. Some of you can jump real quick, and I heard it in the back, and that's great. But let's just jump step by step just in case. How would we undo the 1 over?
Multiply by negative
Yeah.
power.
We can say square root of e to the negative 1. Okay, it's not pretty, but some of you are just going to want to jump, and that's going to be great. I'm just trying to show you what's going on. We could make this to the negative 1 power because it's underneath 1. What can I do with the square root? Remind me. Yeah, he's jumping, but he's got it because I can make the square root into a 1/2. It's times the negative 1. Does that make sense? Just in case, I'm going to do e to the 1/2. That's the square root. But we could, a lot of you, hopefully, are getting to where you might have been able to jump to the negative 1/2. It's a 1/2 power in the denominator. Maybe you could jump all the way through. Well, how did that help? ln of e, what's the big deal?
It's
ln of e, they undo each other. And if you need to see it, remember, this is technically improper, but if it helps you see, I don't mind. Showing it just for a bit. I'm just going to put little quotes to be like he's not really supposed to be there. Remember, ln is really just log base e. So log base e of e to the negative 1/2 is just what? However you think about it, that cancels, the power is left, or the power comes down, and that's 1. Either way. we end up with negative 1/2. Dun 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 dun.
What?
Maybe some of you can get there faster than even someone could punch it in their calculator and be like, anyway, that's one done. Any quick questions on it?
Yeah. Can you do that with like the quotient where you do ln of 1 and 0 and then minus?
Oh, over here. Yeah, you totally could. Hold on, wait. There is another approach. Tyler has a good idea. He says, wait a minute, I would have thought quotient property. How many of you guys thought quotient property when you looked at it? Okay, not bad. A few. Okay? The other alternate approach would have been, well, yeah, we can rewrite this as ln of 1 minus an additional ln of e to the 1/2. I'm just going to jump there. We just talked about him. We talked about any log of 1. Who is that?
0.
0 minus, that cancels. 1/2 comes down. Perfect. Either way, it's totally golden. Either way. Okay, one more example. Ooh, it's a little tricky expansion one. We did a tricky condensing one. How about you guys? Last example. Let's do this again. You, yourself, and you. Using the properties forwards this time. Try to make that expansion. All the properties. Single logs, multiple. Well, single ln. Right? Don't get tricked. Make sure it's all people. No illegal activity in this room.
It's like not
Yeah.
just regular physical activity.
I care about more than just math.
Darn it.
You know a good thing. I literally just cared about math.
I would copy
Homework would be fun.
I don't know.
I know you guys would love to get some work done, so I'm not going to have you collaborate and group this time. From the back of the room, you're supposed to do that.
If teacher can look at what can't be that.
Did anybody subtract?
Yeah.
Real quick, high fives, everybody in your group. Oh no, we have people falling asleep. We only have to stay alive for a few more minutes and then work to get, well, be more alive tonight. Maybe more alive in the morning to get more sleep tonight. Please, time up. Who used subtraction?
Me.
Wait, more high fives. We need more high fives. We're falling asleep. Oh no. Pat in the back or something, I don't know. Haley doesn't want a high five from either.
Big hands.
Yeah, you do.
Okay. So now that we're not hurting each other
I
anymore.
broke something.
What'd you guys write? Help me out. What's the first thing? LN, because it's an LN, it's going to stay an LN. That doesn't change, right? Of who? Read it.
Oh,
6. Now, wait, pause, calm down. You two. I apologize. Kind of asked for it, but still. Okay, coming back. I'm sorry if you're hurt.
Ow.
6 divided by. What do you change that to?
Subtraction.
Subtracted an additional ln. Ooh, did you do that? Okay, then you can do the bottom. Square root of x squared plus 1. I'm showing all the steps, remember? What am I going to do next?
Square. Square the x.
I can only square if I square both sides. Don't square. Make it into what power?
1/2.
Nice. ln of 6 minus ln of x squared plus 1 to the 1/2 power. What can you do with the power? Pop it. Pop it on down. ln of x squared plus 1. ln of 6. Who kept going?
Nope.
If you did, there's no shame in it. It's one of the most common mistakes made with logarithms. You see the plus and you're like, I can make it times, and then you mess it up. Question. Look at your 3 properties. Is there any property that says single logarithm of an addition goes to anything?
No.
Nope. Addition has to be 2 separate logs, and I don't have it. So we're stuck. Dun 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 dun. Literally. Jason, go.
Okay, so you know the square root on top of that.
Why can't I just cancel with this? Yeah, I was thinking that.
Good
You
question.
just killed something.
You did, technically. But let's talk about it, because it's a common mistake.
But if you square root x plus, or x squared plus 1 equals
Why?
x plus 1.
Does this not equal that? Let me show. Ready? I've shown it a couple ways. Let me try showing you a new way. If you square both sides, shouldn't they be equal? If they were equal. Square this side and you get x squared plus 1. Square this side and you get... Sadly. But, good idea. Good idea. If we could factor it to be x plus 1 squared, we would have been golden, but we can't. So therefore, we're stuck. And we have to approach it the way that we can. Long story short, a puppy would have been killed.
Tyler Point proof.
I
Football
said would have
players.
been killed. Maybe it did.
So
Okay.
we did that on purpose.
Let's see, anything else? Dun, 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 dun. Anybody, start your homework and have a few questions. I'm going to pull up the homework right now. Remember, those of you that haven't started can glean from their experience. There are a few extra books up here if you want to come grab one. Even or odd, anything we got stuck on? I'm reading anything.
Oh, watch it. Number No, you don't get help. Nathan, look at my
Number.
Basically, like field trip.
No.
All right, anybody else start homework and get started? 39?
You can't do it.
Okay, yeah. 16 to
I'll donate to $1 for children.
David.
Wait, what did he do? Did he give you a high
No, I
five?
just saw it.
Why? Hands are keys. Don't you hands?
Good hit, bro.
They're ginormous. Oh my goodness.
Change it. Good hit.
Let me see.
Like his hands are
So,
He wasn't.
Look at that. Stomp on it. Look at my feet. Wait, change it.
I say you just say that's not realistic and I'll never have to face it. Done.
But if you did.
Who's gonna give $1 billion for stomping on a puppy? You guys are so messed up. All right, so, I mean, you are all lovely children. All right, so,
That's so sad too. I wouldn't have to get rid of it.
I'm not sure this was the intended purpose of my signs. Thank you, though, for going there.
Yeah, for teaching high school.
You don't have to kill it, you just step on it.
Wow.
It's just laying a bunch of tiny legs.
I'll donate to a dog association.
You didn't do anything wrong, did you?
It does like I hired 69.
All right, kiddos, hold on, time out real quick. If anybody in your group does not have the homework written down yet, can someone in their group just show them their spiral real fast? If anyone has it written down, can you just show it to your group, make sure everyone has it? Just check real quick. Some people didn't get to write it down. My computer is freezing and trying to get to the problems that we have.
Did somebody say 9?
No, you won't get mine?
I can barely read that either.
Let me try one more time.
No, wait for it.
Don't get lost.
Press cancel. Press cancel.
Can't press cancel? That just doesn't. Oh, there we go.
It's too late.
Oh, I don't know, Cameron.
Okay, I'm trying one more time. I hope we have it this time. Section 3.3.
Okay.
So that's fun.
Did we ever do number 9?
We did.
Yeah, someone asked about number 9. We're getting there. 9, 16, and then 39 are the ones I heard. Oh, come on.
Every single one. Oh, makes sense. There it is.
Yeah.
Why are they making us expand and
Oh, okay, that's not good.
logarithms?
Because in calculus, without that skill, some problems are ridiculously hard. So it's basically you're building up to something in the future.
We're still building up? Is that why it's
Yeah.
called
Yeah. It's like pre the rest of math, pre-physics, pre-calculus, pre-statistics,
So we're basically like all pre-cal is just learning all the
pre-everything to come.
basics, learning the base.
Kind of. The base of how to use all that you've done to be able to go a little bit further.
And calculus is when we're actually like,
When you're kind of starting to branch off in a certain direction towards certain applications.
where it's not just like random.
Like it's a cohesive.
Like
Yo,
some calculus deals with like stuff that you would usually use in like real life if you wanted to be.
Wait guys, is this section 3.3?
No,
This is wrong, right? Ah, it's 3.4. I didn't think it looked right. There we go. Ricky, this was your number 9, right?
Yeah, I got it now.
Does anybody else need number 9 still? That's a little bit tricky. Let's go for it. We had 9, then 19. It's okay, you survived. 19.
I was scared.
And then 39.
Okay, I'm on 65. That's so creepy. Like, they can shoot through the window. One die. We legit. What?
Ignore the line, I got annoyed. Okay.
Bless.
Thank you. Alright, kiddos, real quick. You've had a little bit of time, some of you got your spirals updated, so you're ready to go with what the problems are. But since we did have 3 questions, we're going to quickly zoom on in. We're going to quickly zoom on in. We're going to quickly zoom on in. We're going to make sure that we understand these ones that some of the other kiddos have gotten a little bit further possibly than you had. Number 9, I think just the directions are tricky more than anything else. It says rewrite as a ratio. Wait, ratio, division. Of common logs? Common logs? That's a log base x. Oh, I think we're changing the base. Is there a formula for how to change the base? What is it?
Log of x.
Oh yeah, the x, that's true. I'm just gonna keep the u though, just because that one has an x, it'll get confusing.
Log of u.
No idea. Wait for it. Okay.
Do you watch
Wait, do you watch
Psych?
Psych? Wait, no, is that like, that's a genuine question. Do you?
It's not on Netflix anymore though. But I actually watched it when it was originally on TV.
So did I.
All y'all.
I watched the last
Come
season. I was a little kid, my parents wouldn't let me watch it. And my little kid was like 13. My parents were very
That's actually
young.
pretty clean though.
Yeah.
It is
We
it's
had like a mummy that would want it. Come back. What's the formula?
Is equal to log of
Which one?
u.
The big one over the base, the old base. So how would you apply that over here? I'm just going to do one of them. You guys get to do the other one. It says first common log, right? So I'm making him into common log of who? Who goes first?
3 over 10.
3 over 10, all over common log of x. Something like that.
Wait.
You have to do B. Huh.
What about the quotient property?
Or, if you want to be really snazzy,
Yes, turn good.
log of 3 minus log of 10 all over log of x.
So with 7.
If you want to be really snazzy, you could use the quotient property if you would like. Either one works. They're both the same, right? No judgment. The book probably has that one. That one's pretty spiffy, though. Alright, guys, hold on really quickly. Remember the whole talking over me thing?
Sorry.
I'm hearing it. Been hearing it. We gotta focus on it. We have 2 more questions that people had to ask. But anyway, these are the same thing, different variations for A. B, just make it ln. Okay, number next one. I think you guys had number 19. That's the question that someone had. No, 16, right? 16, sorry, wrong one.
Oh, wait, not 7. I got 6.
You got 16, yeah. Let me peek at 16 real quick for others too. I'll peek at both real fast. What are the directions? They don't say expand or condense, they just say use the properties. Oh well, use all of them. So for number 16, what do you see? Log base 2 of, well, alright, log base 2 of 4 squared, alright, 4 squared, times. Wait, what can you do with times then? Can we do something? Yeah, we can add an additional log, right? Log base 2 of 3 to the 4th. How did that help? 4 is somebody special with 2, yeah? First of all, I can bring down the 2. He's a power. I can make 4 into somebody. We'll get back to that. I can bring down the 4. Any other ideas? What can I make with 4? 2. Why am I going to 2? Because look at his base. So I can make 4 into 2 times 2, or another way of writing it for my power property, 2 squared. And that 2 can pop down. I have 4 log base 2 of 2. Oh, that's right. What's like log base 2 of 2? Remember, you keep the power, right? So it'd be 4 times 1, which is just 4. Oh. He's been chilling this whole time. Can I do anything with log base 2 of 3? No. Not so good. How about going to like decimals and crazy stuff like that? If you really wanted to, could you pull out the 4 and like factor and make it look different? Sure, if you want to. But I can't break down the log base 2 of 3 anymore. I mean, you can't become a power of 2. It's not a nice one. Number 17, that question was added real quick. Any properties, kiddos? Any ideas? Quotient, right? Division. Or we could make it 250 to the negative 1. But a lot of you said quotients. Let's do that first. So keep the log base 5 of 1. Divide means subtract with an additional log, right? An additional log of 250. Hey, what's any log of 1? 0. That just moves away. 0 minus anybody. Well, that's just gone. 5 and 250. I wonder if those are related. How can we figure out how they're related? Take 250 and why not? Let's break them down. Plug in a 5, that would be 50. Plug in a 5, that would be 10. Plug in a 5, that would be 2. So couldn't I make that negative 0 minus log base 5 of 5 cubed times 2? Right? Does that make sense? Why did I do that? But wait, can't cancel anything until I do what? I need to get rid of that 2. How do I separate? How do I expand? How do I move the 2 away? Yeah. Well, I'm not going to do power yet. I need to do product first, just to break off the 2 so I can deal with that one. So we'll do log base 5 of 5 cubed. Times means plus an additional log. There we go. Now I have the 5 and the 5 cubed. What happens with log base 5 of 5 cubed? Yeah, it cancels and becomes a 3. The 3 can go in the front. The log base 5 of 5 just becomes a 1. 3 times 1 is 3. And then what can I do with that log base 5 of 2? Well, not much. Well, those parentheses are kind of messy. Can I bring that negative in? But I had to keep those parentheses, otherwise I would kill a poor little seal and not bring it into boat. As far as I can see. One last question. 39? That was it, right? Expand? How do you expand? Is it really as easy as it looks?
Alright, well, yeah.
Done, not done. Yes, it was. He was like, you can't be that easy. It is. Alright, kiddos, hopefully you were able to start homework. Write down homework. We have a couple more minutes here, Elena. Got you. I'm putting back up the homework assignment for those of you guys that might not have been able to write it yet. And you guys have a few more minutes to get done as much as you can. Here you go, kiddo.
You have one of That's what I want right now. There's a lot of space to work with.
Well, when you go to rewrite,
Oh, yeah. You can use it now, Don.
Caleb.
Alright, ready? I'm only gonna say this once.
and one has shown on the outside.
Let's do it.
There might be a power that can slow it down.
So for this one right here,
Word plus
you can
log,
obviously
you
do
have
power
log
Yeah.
base 2.
And then with this right here, can you like split it up like that or no?
No, that's perfect.
That's 12.
Now you have division.
so would each one be 1/2, 1/2?
Good. Because the one half thing we didn't, it distributes to both half.
Well,